the chemistry lab. So this in chemistry practical is very important part. Okay. So in BTech first year there are 6 experiments. So today we will tell you about one of the experiment. The aim of the experiment is to determine the concentration of ferrous and ferric ions in the given solution. Okay, so here in this one solution mixture is there in which both the ferrous and ferric ions are present. Okay, so you have to determine the ferrous ion concentration and ferric ion concentration separately. Okay, for this so you have to do some experiment here. So if you see this the reactions in this for titration, okay, you can determine this ferrous and ferric ions by titration. Okay, so in this experiment the ferrous ion is very easily determined by titration. Okay, so here the ferric you have to convert in ferrous, then only you can determine the ferric ion concentration. Okay, so the ferrous ions you can determine by titration. Okay, so the reaction, if you see the reaction here it is ferrous ammonium salt is there, suppose. So here it is Fe is in +2 state. Okay, ferrous ammonium sulfate. Okay, it reacts with potassium dichromate. Okay, and giving here this ferric sulfate plus potassium sulfate, ammonium sulfate, and chromium sulfate. Okay, so in this reactions iron is present in +2 state. Okay, it is converted to iron 3 state here. Okay, and the chromium which is present here in +7 state, and here it is converted to +6 state, oxidation state. So it is oxidation reactions. Okay, so this reaction. Okay, so in titration here ferrous ion it is react with this potassium dichromate and giving this type of this reactions. Okay, so in this titrations you need one indicator. Okay, so that only you can see the end point. So here the chemical which is required in this experiment, what chemicals are required for this titration? Ferrous ammonium sulfate, that is called more salt. The other is potassium dichromate solution, an indicator, and fourth one is zinc dust. Okay, so this things is required for titrations. Okay. So this in this experiment there are 3 parts. The 3 parts, one is standardizations of potassium dichromate solution. Second is determination of ferrous ion, and third part is determination of total iron, that is ferrous and ferric ion are present in the solution. Okay, so there are 3 parts. Okay, so here what we do, okay, first we standardize this potassium dichromate, okay, with the help of the standard solution of ferrous ammonium sulfate. Okay, so and then if in that case from standardizations we know the standard the exact concentration of potassium dichromate, and with the help of this the exact concentration of ferrous ion solution or the ferric ion concentration in the solution. Okay, ferrous ion concentration in the solution and the total ion concentration in the solution. Okay, so this is required. Three parts is there. So in the first case, we take this 10 ml of standard solution of ferric ammonium sulfate, and we titrate with potassium dichromate. Okay, by using this the N-phenylanthranic acid as an indicator. So in this, so you can see here, this reaction is happen in the presence of acid. Okay, so here acid, dilute acid is also required. Okay, so here, so first we take the 10 ml of ferrous ammonium sulfate in the conical flask and add half test tube dilute H2SO4 and 3-4 drops of N-phenylanthranic acid, and we titrate with potassium dichromate. So from this we get the volume which is required for this titration. Okay, for 10 ml of ferrous ammonium sulfate solution. So this volume is known as V1 solution is required. Okay, so for this standardizations. Okay, so this, now we go to this sheet. How we will do this again? So now we start the experiment. The first part for standardizations of potassium dichromate solution with the help of standard solution of ferrous ammonium sulfate. So we take 10 ml of ferrous ammonium sulfate in the conical flask. Okay, so with the help of pipette. Okay, so it is a 10 ml pipette will be there. So we are taking 10 ml ferrous ammonium sulfate in this conical flask. Okay, so after adding this ferrous ammonium sulfate, we add half test tube. Okay, half test tube dilute H2SO4 in this conical flask. So just H2SO4 and 3-4 drops we add here N-phenylanthranic acid as indicator for standardizations of ferrous ammonium of this K2Cr2O7 in this experiment. Okay, so no, okay, you shake this conical flask and now this is the color change. So this is your end point.
Red violet.
This red violet color. So you can see this the volume. How much volume is required for this titration? Okay.
9 point.
How much it is?
9.5.
Okay. So it is 9.5. For 10 ml of ferrous ammonium sulfate, it is required 9.5 ml of potassium dichromate. So this volume 9.5, it is V1. Okay, so this much volume is required. Okay, so this we again repeat this experiment so that we can get the same value of this volume of potassium dichromate. Okay, so we repeat this till we get the same reading, means concurrent reading. Okay, if we are not getting the concurrent reading, then again we will repeat. Okay, so when we get two value are the same value, these values are known as concurrent reading. So we again repeat this. Okay, and suppose that it is a concurrent reading. So this is your first part of the experiment. It is the standardizations of potassium dichromate with the help of a standard solution of ferrous ammonium sulfate, and the concentration or normality of ferrous ammonium sulfate is n by 20. Now you come to the for the second part of the experiment, the determination of ferrous ion in the mixture. Okay, so here from the mixture we take this 10 ml of this mixture in a conical flask. So we are taking here, and we add here a half test tube dilute H2SO4 and 3-4 drops of N-phenyl anthracic acid as indicator. Okay. Yes. So half test tube this dilute H2SO4, and then add 3-4 drops N-phenyl anthracic acid. This is again we titrate with potassium dichromate. The burette is filled with potassium dichromate and initial reading is 0. Okay, so we again titrate this. So just we start this titration. See the readings. Point of the second part for the determination of ferrous ion in the mixture. Okay, so in this case how much volume is required in this?
6.9. 6.9. कितने में
लगा दीजिए, अगर सिग्नेचर कर दिया वो
7 पॉइंट है।
अच्छा ठीक है, तो कर दीजिए। After this second part of this experiment, after the titration of this the second part, we got the volume of potassium dichromate. It is 7.5 ml of potassium dichromate is required for 10 ml of the mixture. So from this volume 7.5, it is V2. Okay, so again we repeat this so that we can get the same value, otherwise it is not the correct value for titration. Okay, so we can repeat so that we can get the same value, two value of the same value. Okay, so in this after that the third part of this experiment. So in this the second part, the mixture, it is this red violet color will be there. So in this same mixture we add the concentrated H2SO4 half test tube and zinc dust for reduction of iron 3 into iron 2. Okay, so zinc dust you add here. So few punch of the zinc dust. One more. Okay. So now you can see the reaction. Okay. So reaction is happening here. It is okay. So this iron 3 is converted to iron 2. Okay. So one thing here we have to add in the second titration, which is ferrous ion converted to ferric. Okay. So here now after addition of sulfuric acid, the concentrated sulfuric acid and zinc dust, now this in this solution all the iron it is in 3 state. Okay, so total iron will be there. In this total iron will be there. So it is exothermic reaction. So we just wait for cooling here. After cooling, we again titrate for this titrate with the help of potassium dichromate. Okay, so now we titrate this. So here we add dropwise potassium dichromate. Okay, dichromate and shake regularly. So this is again at the end point. This is again it is red violet color will be there. So red violet. Okay. So okay. We have done the experiment for the calculation of iron 2 and iron 3 in this experiment. So there are 3 parts of this. One is standardizations of K2Cr2O7. Second is the calculation of ferrous ion concentration, and third part is concentration of Fe3 plus Fe3 concentration. Okay, in this solution. So we have done 3 part of the experiment, and we got the volume of K2Cr2O7 in the experiment used for first part. It is the first part. The volume it is coming 9.5 ml. Okay, for the 9.5 ml of K2Cr2O7 is required for titration of 10 ml ferrous ammonium sulfate. Okay, and in the second part, the volume of K2Cr2O7 used for second part it is 7.5, and in the third part, volume of K2Cr2O7 used for third part it is 11.5. Okay, so here one thing is very important. Here after titration on this second part, the first part is this second part titration. Okay, here we have used the zinc dust and concentrated sulfuric acid. So as you seen the earlier equation, chemical reaction, so Fe3 is converted in the second part, and when we used the zinc dust, that Fe3 will be again converted to Fe2 plus. Okay, that's why in the third part of the experiment, the volume of K2Cr2 used, okay, here it is higher than this value. Okay, here it is, this volume is for total iron. Okay, this total iron concentration in the mixture. Okay, so the calculation, how we calculate this? So here calculation for the first part, okay, the standardizations of K2R27. Okay, so here suppose this concentration of normality, okay, N1 volume used for this it is V1, and this ferrous ammonium sulfate normality it is N2. Suppose here and here it is the volume we have already taken 10 ml. Okay, so here we have to standardize this K2Cr2O7. So we just suppose this normality is N1, So this N2, it is not value 1 by 20. It is 1 by 20, okay, and V2 it is a 10 value, 10 ml of ferrous ammonium sulfate we have used, and this V1 used for this second part of the first part of the experiment, it is 9.5. So if you solve this, the exact concentration of K2Cr2O7, it is coming 1 by 19, okay. So this is the actual concentration of the K2R27. So this things will be used for the other titration. So the second part, the calculation of iron 2 concentration. Okay. So here for second part of this iron 2, how we calculate this? Suppose here K2Cr2 is used for this titration. So here it is N1, we have already written there, this mobility is N1. K2, it is the volume of K2Cr2O7 is used for this titration. And here mixture we have taken 10 ml of the mixture, and its concentration, normality, we suppose here it is N3. Okay, so these things we have to determine. So N3 value, it is N1 into V2 by 10. Okay. So here N1 it is already known from the first part. It is 1.19, and it is this 7.5 this V2 is used for this titration, and 10 ml of this solution we are taken. Okay. So if you solve this, so this value is coming 0.039 normal solution. Okay. So this so you can convert this gram per liter just by multiplying by 55.5. Okay. So this you can determine the iron 2 in terms of gram per liter just by multiplying by 55.5. Okay. So the third part calculation, here it is. Third part is concentration. Okay, iron 3 concentration. Okay, so for this, here you can see here this is V3 is the total iron. Okay, this is total volume of K2R2O7 used for the total iron, and it is for ferrous iron. So you subtract this V3 minus V2, it gives the ferric iron concentration present in the solution. Okay. So suppose here, so this is this formula we have used for this N4 concentration of the ferric iron solution. Okay. So N4 it is N1 V3 minus V2. Okay. So this divided by 10, and it is coming 0.021 normal. So again you can get the gram per in the form of gram per liter, but just by multiplying by 55.5. Okay. So this is all about this experiment, how you can determine the iron plus 2 and plus 3 in a mixture of the solution. Okay. This is all about the experiment.